Hi Sky. Today I will to talk about Chapter 4. It's a new chapter of the computer network. This is a network layer. Outline. Uh, the 4.1's introduction network layer protocols. Unicast routing, multicast routing, next generation IP. Objective. We first discuss services that can be provided at the network layer, packet sizing, routing, and forwarding. We then discuss the network layer as TCP/IP suite, IPv4, and ICMPv4. We also discuss IPv4 addressing and related issues. We then concentrate on unicast routing and unicast routing protocols. We then move to the multicasting and multicast routing protocols. And we finally discuss a new generation of the protocol IPv6 and ICMPv6. Introduction. Figure 4.1 shows the communication between Alice and Bob at the network layer. This is the same scenario we used in Chapter 2 and 3 to show the communication at the application and transport layers respectively. It's figure 4.1. Network layer service. Before discussing the network layer in the internet today, let's briefly discuss the network layer service that in general we expect from network layer protocols. Packetizing, routing, forwarding, error control, flow control, congestion control, quality of service, and security. Forwarding process. Packet switching. From discussion of routing and forwarding in the previous section, we inferred that a kind of switching out occurs at a network layer. A router, in fact, is a switch that creates a network connection between an input port and output port, or a set of output ports. Just as a electrical switch connects the input to the output to let electricity flow. Switching technical circuit switching and packet switching, circuit switching at a physical layer. Packet switching as a network layer, the unit of data is packet. Next, the connecting device. A packet switch network decided to route the packet to a final destination. Two different approaches to route the packet: datagram's approach, visual circuits approach, datagram approach, visual circuits approach, setup phase, data transfer phase, data phase. Figure 4.3. The connection layers packet switching network. A datagram approach connection service. Each packet independently having no relationship to an other packet. The network layer delivery of the packet from the source to the destination packet. The packet messages may or may not travel to same path to their destination. forwarding process in router when using a connectionless network. Each packet is routed based on the information contained in this header. Source and destination address, the destination address where it should go, the source address when it comes from other messages. In the diagram, approach the forwarding decision is based on destination response. Visual circuit packet switching network. A visual circuit approaches the connectional oriented service before sending a visual connection should be set up to define the part of datagrams after connection setup. The datagram can follow the same path. The packet, the source and destination address are flow label. A visual circuit identified. Okay. Next is forwarding process in a router when used in a visual circuits network. In visual circuit approach, the forwarding decision based on the value of the label visual circuit identifier of the packet. To create connection-oriented service, a three-phase process of data transition. The source and destination address to the sender and receiver use to make the source and destination inform to the router to delete the corresponding entry. Sending request packet in the visual circuit network. A setup phase to router create any entry for visual circuit to accessory and packet exchange to request packet and acknowledge packet. Sending an acknowledgement in a visual circuit network. An acknowledgement packet are computed in the entered in the switching tables. Flow of the one packet in the established visual circuit. Network layer performance. The upper layer protocols that use the service of the network layer expect, receive an ideal service, but Ethernet network is not a perfect. The performance of a network can be measured in terms of delay, throughput, and packet loss. We first define these three terms in the packet switch network before we discuss their effects on the performance. Delay, transmission delays, propagation delays, processing delays, queuing delay, and total delay. Throughput, packet loss. Throughput is the part with three links in a series. In a path of source to destination, a packet may pass through several links network, each with a different transmission rate. How then can we determine the throughput of the whole path? In a path with a link in series, throughput minimum TR1, TR2 to TRN. The average data rate for this path is 100,000 bit per second to minimum of 3 difference. Bottleneck the pike with the smallest diameter. A part 2 Internet backbone. The actual situation in the Internet to Access Network and the Internet backbone, the minimum of TR1 and TR2. Effect of throughput sharing. A router may connect the flow from several sources or distribute the flow between several sources. The transmission rates of the link between two routers are shared between the flows. Transmission rate of the main link in the calculation of the throughput only 200,000 bits per second because the link is shared between three parts. Network layer compression. In Chapter 3, we discussed compression at the transport layer. Although compression at network layer is not explicitly addressed in the Internet model, the study of compression at this layer may help us to better understand the cost of compression at the transport layer and find possible remedies to be used at the network layer. Compression at the network layer is related to two issues, throughput and delay, which is discussed in previous section. Compression control, handled by either the source or the destination. Open loop compression control, prevention. They have a retransmission policy, window policy, acknowledgement policy, discarding policy. Closed loop compression control, blood pressure, shock packet, impacting signaling, explicit signaling, packet delay and throughput as a function of load. Blood pressure method of evaluating compression. Shock packet. Structure of a router. In our section of the forwarding to routing, we represented a router as a black box that expects coming packet from one of the input ports. Interface use a forwarding table to find the output port from which the packet departs and send the packet from this output port. In this section, we open the black box and look inside. However, our discussion won't be very detailed. Entire books have been writing about the router. Just give an overview of the reader. Continue. Components: input port, output port, routing processor, switching fabrics, crossbar switch, banyan switch, basher banyan switch, router components. Input port. In the input port, perform physical and a link layer functions of the router. A bit are constructed from the received signal. The packet is decapsulated from the frame, checked for errors, and discarded if corrupted. The packet is then ready to be processed by the network layer. Output port perform the same function as an input port, but in the reverse order. First, the outgoing packets are queued, then each packet encapsulates a frame, and finally, the physical layer functions are applied to the frame to create a signal to be sent on the line. A crossbar switch connects an input to an output in a grid using electronic micro switch and each corresponds Banyan switch, a multi-stage switch with a micro-switch at each stage that routes a packet based on output port and represented as binary string. Example of routing a Banyan switch. Partial Banyan switch. The problem with a Banyan switch is a possibility of internal constitution, even not the same output port, by sorting the outgoing packet based on the destination port. Xinh trong quá sạch. The sorting switch uses hardware merging techniques. Another hardware module tab prevents a duplicate packet. Only one packet for each destination is allowed at each trip. Summary. A summary: the Internet is made of the many networks or links connected through connection device, each of which acts as a router or a switch. Two types of switching are traditionally used in the Internet: the in-networking, circuit switching, and packet switching. The network layer is designed as a packet switching network. The network layer supervises the handling of packets by the underlying physical networks. The delivery of the packet can be direct or indirect. Two categories of the following are defined: following based on destination address of the IP and following based on the label address.